Good morning. Today's my topic is about hardening and normalizing in heat treatment process. Introduction to heat treatment. Heat treatment is a group of industrial and material working process after used to alter the physical and sometimes chemical properties of a material. The most common application is metallurgical. Heat treatment involves the use of heating or chilling, normally to extreme temperatures to achieve a desired result such as hardening or softening of a material. Heat treatment techniques include annealing, case hardening, precipitation, strengthening, tempering, and quenching. Today we learn about hardening and strengthening of a material. Heat treatment encompasses various processes to alter the physical and sometimes chemical properties of material. It is primarily used to improve mechanical properties such as hardness, ductility, and toughness. Two common processes in heat treatment are hardening and normalizing, such as serving purposes. What is hardening? Hardening is a heat treatment process aimed at increasing the hardness of a material, that is typical metals. It involves heating the material to a specific temperature and then rapidly cooling it, usually by quenching. The rapid cooling transforms the microstructure of creating a harder but more brittle materials. This is case hardening process. In this, steel rod is heated up to its temperature by gas air control. Hardening process steps. The hardening process starts with heating the metal to its austenizing temperature. After holding at this temperature, the metal is quenched in this medium such as water or oil. The final step often includes tempering to reduce brittleness while maintaining hardness. This is hardness and tempering process. Types of hardening. There are various types of hardening process, including water hardening, oil hardening, and air hardening. Each type has different cooling rates and results in varying properties of the treated material. The choice of hardening method depends on the type of normalized and the desired mechanical properties we have. What is normalizing? Normalizing is a heat treatment process that refines the grain structure and relieves internal stresses in metals. It involves heating the metal above its critical temperature and air cooling to achieve uniform microstructure. The process involves toughness and workability while material advocates strength. Normalizing process steps. The normalizing process begins with heating the material to a temperature typically 30 to 50 degrees Celsius, the upper critical temperature. The material is held at its temperature for a specific period to allow for complete transformation. Finally, it is air-cooled, which helps to accept fine-grained structure and uniform properties. Microstructure of normalized perlite after annealing and normalizing. The perlite has changed its phase from bigger grain to smaller grain, and large crystals of ferrite has been changed to small crystals of ferrite. Before annealing process, the core crystal structure is formed. In normalizing ferrite as at boundaries in center of crystals. You can see in this picture about annealing and normalizing. Difference between hardening and normalizing. Hardening focuses on increasing hardness and strength, while normalizing aims to refine grain structure and relieve stresses. Hardening usually results in a harder but more brittle outcome, whereas normalizing enhances toughness. The cooling methods differ significantly. Hardening often employs rapid quenching, while normalizing used Normal quenching. Applications of hardening. Hardening is a widely used in manufacturing tools, dies, and components that require high wear resistance. It is essential in applications such as automotive, aerospace, and mechanical machinery industries. Proper hardening can significantly extend the parts subjected to high stresses and wear. Applications of normalizing. Normalizing is commonly applied in structural steels and components to achieve more uniform properties. Industries like construction and manufacturing utilize normalized materials for improved performance and reliability. It is particularly beneficial for the parts of machining and needed a stable microstructure. This, I conclude, both hardening and normalizing are crucial heat treatment process with specific applications and benefits. Understanding the differences help in selecting the appropriate process for desired material properties. Proper applications of these processes can enhance performance and longevity of life. Thank you.